All right, hi everybody. This is the Math 31 Limits Review. We're looking at question 3b. What we need to do is we need to sketch this piecewise function and then discuss continuity at x equal to 0. Okay, so we've got 1 minus x squared, 2x plus 1. And then we're piecing them together when x is equal to 0. Now, as has been stated before here, the only place where there could be an issue of continuity can be at 0, because these are both polynomial functions, and all by themselves, polynomial functions don't have any issues over their domain. So we just have to check and see what's going on here. So now let's take a quick look. Let's zoom out a little bit so we can see the graph as we're plotting it. So the first thing I'm going to graph here is y equals 1 minus x squared. I'm going to do this where x is less than or equal to 0. Okay, well, I mean, you spent a whole course on quadratics with Math 20. So this is a parabola that opens down, okay, and has a vertex at 0, 1. So this is going to start here. If I go 1 over, 1 down, 1 over, 1 down. If I go 2 over, that's going to be 4 down. So 1, 2, 3, 4. I'm going to go down to there. And same thing over on the right. So this parabola is going to look something like that. Okay, now, but this is only defined on the domain where x is less than or equal to 0. Now, that means that where x is equal to 0, so right there, the vertex, I'm going to put a big circle and I'm going to fill it in because it's or equal to. But then I only need the part of the curve where x is less than or equal to that. So I don't need this part to the right. So I'm just going to erase that. I don't want that anymore. That's the only part of that first function that I actually want. Okay. Then I move my attention to the next one. The next function here is y equals 2x plus 1. Okay, well that's a line. It's got a slope of 2 and a y-intercept of positive 1. So there's the y-intercept at positive 1. Got a slope of 2, meaning it's going to go up 2, 1, 2, over 1, up 2, over 1. Or I could go from here, down 2, back 1. Okay, down 2, back 1. Now, when I connect those dots though, I'm going to get this line right here. Now, I'm not going to bump into this again because I already know that I'm limiting the domain here. I want this to be where x is greater than 0, which means I would put a circle around that point right there. However, it's already filled in. So just by default, that circle that I put over that will be filled in. And then I'm only interested in the part of the curve that runs to the right of that where x is greater than 0. So I get rid of that part of that curve that's to the left. And that's the piecewise function that I'm interested in. Now, let's consider what's going on at x equals 0. Well, just take a look at it. F of x is continuous, okay, at x equals 0. Why? Well, because the limit as x approaches 0 from the left of f of x is equal to the limit as x approaches 0 from the right of f of x. And that's great, and I need that to occur, but all that does is guarantee the existence of the limit. That doesn't actually guarantee continuity. Okay, so that's true. This gives me a limit, but more importantly, the limit now as x approaches 0, now that I know that exists, is equal to f of 0. So the function itself is equivalent to the overall limit, which means the function exists at that point. It's continuous there.